Here's the next activity that you need to work on, which is dealing with linear equations with brackets. And you saw in some of the previous examples how this might happen, or you'll see a lot of questions where the brackets are in the question. So here's a couple of examples. Now, there are two ways of dealing with these, thinking about our order of operations and the way that we can do that. But I'll show you that one of the ways will actually work all the time anyway. But I'll show you the two possibilities. Now, if we're looking at this first example here, this is a very typical example where our reverse order of operations, so doing the multiplication before we think about the brackets, would work. So in this case, I've got everything in the brackets is being multiplied by 2, so the opposite operation would be to divide both sides by 2. These will cancel, then what I'm left with is x plus 3 equals 5, and then I will take 3 from both sides, and what I'm left with is x equals 2. Now that is following the process that we've talked about previously, and it will work. Where it becomes a problem is in examples like this one over here. If I was to divide both sides by 6, then I would cancel the 6 on this side, but then on this side of the equation I'd have an improper fraction. I'd have 11 over 6, which is not as easy to work with later on. So when we're then doing our addition later on, we'd have to add the fractions, and that's just a bit of a pain. So one way that will solve the problem of having awkward fractions, and it will always work, so we don't really need to think about doing things this way particularly, is just to expand brackets whenever we have them. You can't really go wrong if you do this. So I will expand my brackets, so I've got to make sure that everything in the brackets is multiplied by everything that's outside the brackets. So firstly, 6 times x is 6x. 6 times minus 2, being careful with directed numbers, is minus 12. Now this equals 11. I haven't done anything with that side of the equation. Then the next thing I'm going to do, well, we're back to our normal order of operations, where when we're solving equations I'll do addition or subtraction first. So my opposite operation there is to add 12 to both sides. So these will cancel. On the left hand side I'm left with 6x. On the right hand side I'm left with 23. Now we're still going to end up with a funny fraction, but we're doing it as our very last step. So I'll divide both sides by 6. The 6's will cancel. Now what I'm left with is x equals 23 over 6. But I got to that without having to do any addition or subtraction of fractions and worrying about common denominators and all that kind of stuff. Now, I could probably make that into a proper fraction, but to be honest, the improper fraction is perfectly good as an answer. So key skills, expanding, you have to be careful that you're doing this properly. So you can use crab claws or foil or whatever technique helps you to remember how to expand. But the main thing is that everything in the bracket is multiplied by what is outside the bracket. And then we've got to be careful with things like directed numbers. So the first thing we've got here is minus 3 times x. So it's a negative times a positive. We end up with minus 3x. Then minus 3 times minus 5. Well, 5 3s are 15. But it's a negative times a negative, and as you saw in the previous examples, or the previous section, that's a positive. A couple more examples quickly. 7x minus 5 equals 28. Now this is one where 7 goes evenly into 28, so we could approach it this way, of dividing both sides by 7. These are going to cancel. X minus 5 equals 4. Then I'll add 5 to both sides. Then they will cancel over there again. So I've got x equals 4 plus 5, which is 9. With this example down here, that's not the case. 6 doesn't go into 7. So rather than trying to divide, I'll just expand my brackets as my first step. 6 times x is 6x. 6 3s are 18 equals 7. I'm going to subtract 18 from both sides. They will cancel. I'm left with 6x equals 7 minus 18. So careful with the directed numbers again. Minus 11. Divide both sides by 6. Cancel there. X equals minus 11 over 6. Now I just would like to show you as well that if I approach this top example the other way, so I'll just write that one out again, 7x minus 5 equals 28. If I was just to expand my bracket instead, I'm going to get to exactly the same answer, but I'm just going to take a slightly different way to do it. So 7 times x is 7x, 7 times minus 5 is minus 35, equals 28. Then I'm going to add 35 to both sides. Remember, if you're struggling with any of the addition or subtraction or anything, use your calculator. So what I'm left with on the left hand side is 7x equals, and on the right hand side 28 plus 35 is 63. Then I'll divide both sides by 7, cancel my numbers on the left hand side. 63 over 7 is 9. So you see, either way of working does it. I suppose you could argue that I've done one less step in this equation. I've done, well, let's see, I've done the division. No, that's not even true. They are pretty much equivalent, and expanding brackets will always work. You'll always get to the right answer, and you'll avoid the fractions there. Now, the slightly trickier examples are brackets on both sides. Now, I would suggest with these, just expand both sides. Now, in this case, you do actually have a common factor. They're both divisible by 2, but that often won't be the case anyway. So dividing by 1, well, it might simplify one side, but you'll still have a factor outside the brackets on the other side, and so on. So I would just expand both. So that's what I'm going to do on that side. This is what I'm going to do on this side. 2 times x is 2x. Plus 2 times 3 is 6, equals 4 times x is 4x, minus 4 times minus 1 is minus 4. Then I'm just going to go through the steps of combining my like terms that I've done previously. Now I've got the most x's over here, so I will subtract 2x from both sides. So 2x minus 2x cancels, so I'm left with 6. 4x minus 2x is 2x, minus 4. Then I want to get rid of this from this side, so to cancel that I'm going to do the opposite operation, which is adding 4 to both sides. Cancel that out. This becomes 10 equals 2x. I'll divide both sides by 2, and I'll just swap them over as I'm doing this as well. X equals 10 over 2, which is 5. So you've seen all the examples of brackets on both sides of the equation that we would like you to work on at this stage.